Someone said to me once that they don't think that thrust is the way to go when it comes to propulsion, or that at least the way we achieve it isn't the way to go. And so I have a passion for physics and theoretical physics, and so I started thinking about this on the way home from work. It's now 6 p.m. right now for me. And so I started thinking about the basics, right? F equals ma, the tyranny of the rocket equation. But then for some reason my brain just said time. And then I was working with that time, and I'm like, well, what is time? So then I started thinking about velocity. And I apologize, this is just my ADD train of thought. I started thinking about velocity. You know, how the faster you go, the more energy you need to go to accelerate, linearly at least, right? I was thinking about linear and asymptotic relationships, population growth versus resources required, linear speed increase versus energy requirement, right? You need exponentially more energy if you want to have a linear velocity increase per identical delta in time step, right? All the way to the point where you'll need infinite energy, even if you maintain linear velocity increase, right? Which would require that energy to be exponentially generated. You would reach the speed of light at infinity along that geometric increase of energy. Your energy would skyrocket at I guess it depends on how you graph it. On y-axis, your energy requirement would diverge to infinity at infinity on y-axis, right? And it would converge to zero at infinity on x-axis if you're going a truly zero velocity. But all velocity is relative, so you know. Anyway, I thought a bit more about this, and I was trying to think more dimensionally about things, and I started thinking about how the faster you go, time starts to dilate. General and special relativity, you know, a series of 10 nonlinear differentials that Albert Einstein came up with. He predicted dark stars, or what we know them today as black holes. And I started thinking about time dimensionally. The faster you go, the more resolution you have along your axis of travel to an observer, right? If a car, I apologize, the less resolution you have to a car passing by you on the road, if you're on a sidewalk or whatever, the cars are passing by, their cross section along their axis of travel becomes shorter for you, the observer. Okay, and then you have the Doppler effect of sound, or the you have redshift and blueshift depending on what angle you're observing that object from. That's really all just the truncation or expansion of the same amount of information, depending on whether something's coming towards you or away from you. Information, whether it be audible or visual, but it's all light, it's all EM, right? It's all information. All information in the universe can be distilled down into EM. It's all light. Okay, at least everything gets to the stage of maximum entropy, wants to naturally. But anyway, stick with me here. I started thinking of time dimensionally. The faster you go in space, the less resolution you have in space. But your information does not become more or less. You always have the same amount of information. And I don't want to talk about stuff like you're made of stuff physically, and this is what I reached after thinking about this for a little bit on my car ride home. You know, this is just ad hoc, okay? No research has been done. But I started thinking, well, if my spatial cross-section diminishes in space as my velocity increases, then there must be an inverse relationship between temporal and spatial resolution to maintain the same native amount, but don't think of amount as like physical stuff. Think of amount as more of just a pure dimensionless number for the amount of information you have as a thing, but not necessarily thing physically, more so thing conceptually. And this is where it kind of gets, it does get very metaphysical, but this is what I'm talking about is the faster you go, the less cross-section you have in space and the more cross-section you have in time. Now let's take this to the extreme. Let's get to dark stars or black holes, as Einstein's theory of special and general relativity predicted. That and gravitational lensing and everything. But he also treated space-time as pure geometry, right, in dimension. And he also said, actually I forget if it was Albert or someone else who said that at the center of a singularity, or at least when you pass the event horizon, that is the end of time. So that popped into my head. I'm like, what does that mean? What, the end of time? I'm thinking, okay, wait. The faster you go, the less cross-section you have in space, the more cross-section you have in time, but you have the same amount of information within you, right, that you're made of. When you cross the event horizon of a singularity, right, your spatial resolution becomes 0, but your temporal resolution becomes 100. And perhaps as you get past the speed of light, if you were to extrapolate it from a spatial perspective, you would exceed the speed of light. But from a temporal perspective, you go from occupying very little to infinitely many points in time. But that's the thing that really got me, because time is non-spatial. Time has no distance. Time has no relative point to reference from. Time itself has no relativity. So if your resolution is 1-to-1 in time, then that would mean that the existence of information itself is completely independent from space. And perhaps phenomena like quantum tunneling or entanglement, and how we observe it in a spatial, from a spatial reference point, it seems so bizarre to us, the collapse of the wave function, the Pauli exclusion principle, perhaps things can't exist in the same space because there's not an infinite resolution in time. If your resolution is anything less than 100% in the temporal dimension, then you cannot occupy the same spatial dimension as something else that also has less than a 100% resolution in time. Again, this is all ad hoc. I really don't know what I'm talking about. This is all just thinking about this on the car ride home. And so then I'm like, well, hey, you think about Star Wars or Star Trek, and they're or Battlestar Galactica, Halo, whatever franchise. Hitchhiker's Guide to the Galaxy, they're versions of FTL, or relative FTL. I think maybe Battlestar Galactica, among other scientific franchises, Hitchhiker's Guide to the Galaxy with the infinite improbability drive. What is indeterminism? What is indeterminism? That is the infinite resolution in time that makes it completely indeterministic in space until you collapse that into a point in space, so then you can know what that thing is doing spatially, like quantum entanglement. What you do to one entangled particle happens instantly to another entangled particle, regardless of their spatial relationship. They could be 1 meter away or a light year away from each other. Everything happens instantly to them, regardless of their spatial relationship. Because you do not need space to convey information. It's all from time. Time is the foundation. And the topography of space, which is, we'll say an anisotropic geometry of space, that gradient, that geometry that's created by an object with mass in space, and again, all these things have less than a 1-to-1 resolution in time, that topology in space, that is a continuously variable ratio of space and time, right? If you have an object with mass, perhaps mass comes from the fact that you do not have a 1-to-1 cross-section in time. Information doesn't need to have mass. Mass itself is not information. Perhaps mass is only the result of something not having that 1-to-1 resolution in time. So perhaps when he told me this, he was right. Thrust isn't the way. Perhaps he wasn't thinking about all this, but he was onto something, because it's not. Traversing space is the wrong way to do it. Occupying infinite points in time from a spatial perspective, because remember, from time itself, there's no distance, there's no width, there's no length. Time has no physical dimension. Therefore, everything that has a 1-to-1 resolution in time occupies the same point in time, but at the same time, there's no point in time. Time is infinite. It has no beginning. It has no end. There's no discrete point in time that you can pick. You can't discretize time unless you lower the resolution in time to give some of that to give that amount of information contained in time cross-section in space. And the only way to do that is to reduce the resolution that you have in time to maintain the symmetric, to maintain the symmetry of representation, right? If I'm going a significant velocity, percentage of the speed of light, to where, let's say, time for me is 3 times slower versus time relative to my local reference frame, right? It's always symmetric in the sense, in inverse, right? If time is going 3 times slower for me versus reality around me, that means reality is going 3 times faster versus my reference frame. It's always symmetric, but just flip the sign, right? So considering that, if you lose any amount of temporal resolution that brings you below 1-to-1, that means you have a velocity less than light. That means that you then have a discretized what would you say, a vector in the vector space of space, and perhaps a reflection of where you could be in time, I suppose. I'm talking out of my rear end here. I really don't know, because I'm trying to think of so many things: the Pauli exclusion principle, quantum entanglement, collapse of the wave function, determinism in general, the metaphysics of thought, concept. Like, what is information? Nothing comes from nothing. Time isn't nothing. Time is everything, in the sense that it represents everything. Time represents x over 0. Time represents the most uncountable infinity of infinities. Even beyond infinity, in the sense that infinity can be discretized. Time cannot be itself approximated, unless, of course, you have spatial dimension to take away some of that temporal resolution. But then maintain the specific quanta that you are made of, if you are the information itself that we're talking about here, right? Or a rock, whatever, I don't care. It's just a thing, right, that you can conceptualize. But thinking, that is information that you're generating. And from what? Obviously, the thermodynamics are obvious. But what I mean is, like, metaphysically. From what? You generate thought. Sure, you use what you already know. Your brain is a prediction machine, and heuristics are involved. Yes, that's all well enough understood. I wouldn't say completely, but well enough understood. That's fine. That could be boiled down to determinism, right? Cause and effect. But cause and effect requires a delta in time. But time has no delta in and of itself. It only does relatively according to your spatial cross-section. If your spatial cross-section is anything other than 0, then you have delta in time. Otherwise, time is it is time. I'm not religious myself, and this is going to sound weird. I'm going to say time is God. Mathematically, as far as what I'm working with in my head right now too, quantum mechanically, time is God. It's the closest thing mathematically you can get to God, as far as like the whole infinite, the infinite concept is concerned, right? Time is without quantification. And you can only approximate points in it with actual spatial dimension. But your cross-section has to be such that it's a greater, I don't even know, wait, could your cross-section be negative? Like tachyons? But they travel back in time fast. But if you travel faster than light, would you just go reverse in time? No, that's a completely idiotic concept to me. Because you wouldn't go backwards in time, because if you reach the center of a singularity and time stops, that means that time everywhere else outside of your local reference frame is traveling infinitely fast. You reach the center of a black hole, you've seen all the spatial history that is possible. Spatial reality goes from collapse of the wave function of time to completely, you can see all of it everywhere all at once. If time is traveling infinitely fast, you don't think of speed in the sense of point A to point B. Think of speed in the sense of the rate at which probability collapses into a solution. And remember, a solution doesn't necessarily have to be real in the sense of like imaginary numbers. Imaginary numbers don't technically exist, but they are solutions. And certain formulae who have no real solutions, that in and of itself is a solution. And when you have an infinite cross-section in time and it's and no resolution in spatial dimension, could it be that you have the eye of God? You could see all that was or ever will be? Could you even conceptualize cause and effect then and now versus present? Could you conceptualize any of that if your temporal resolution is 1-to-1? I started talking about propulsion, and now I'm over here in metaphysics. In any event, I don't know what I'm talking about. Food for thought.